All right, boys, so now we're going to be talking about how we use arrows to represent force. We spoke about magnitude and direction, now we're going to talk about arrows. And there's actually a very big connection between the two. So in your notes that you've got printed out, I want you to write your notes in this block here. And I would like you to use these pictures on the back, okay? You'll see when to use those pictures shortly. But if we recap what we said before, magnitude is the measurement, how many newtons, how big the force is. Direction tells us what direction the force is acting in. So now if we jump to force arrows show the force that is acting on an object. So now we're looking at this water bottle right here. So we've got two forces acting on it, one pushing up and one pushing down. And we've used the arrows to show those two forces. Okay? Now the first thing we need to know about these arrows is that the arrows show us how strong the force is and by how big they are. So you can see this arrow is 9.8 newtons and this arrow is 9.8 newtons. If you look at the size of the arrows, they are the exact same. If I made the arrows bigger, it would mean there would be more magnitude, a bigger number of newtons pushing up or down. So the size of the arrow tells us the magnitude of the force. So if I make the arrow bigger, it means the magnitude's bigger. And by magnitude, I mean the number is bigger. The number of newtons gets bigger. If I make the magnitude smaller, then the number of newtons gets smaller. Okay? But these two are the exact same, so they're canceling each other out. Okay? Because 9.8 is pushing up, 9.8 is pushing down, so they're pushing against each other and canceling each other out. Now remember, when you have a measurement of force, we always have a magnitude and a direction. If magnitude is how big the arrow is, direction must be what direction it's pointing in. Okay, so that's the direction the magnitude is acting in. So this one is pointing up. So the 9.8, this 9.8 is pushing up. This 9.8 is pushing down. All right. So, for example, let's take a look at this book. And what I'd recommend is take a moment, pause, and draw the force arrows where you think they're going to be and in what direction they're going to be pointing. All right? Pause the video and try it now. All right, cool. So these are the two arrows, and they are balanced because the desk is keeping the book from moving. So the force of gravity is going down, and the pushing up of the desk should match it. If the force of gravity was bigger, it would pull its way through the desk, and the book would be moving down. If this was bigger, then for some reason the desk would be pushing the book up. I don't know how that would work. But because they're balanced, they're the same size. All right, let's take a look at this one. Try and draw the force arrows acting on this, acting right here. Okay, pause the video and give it a shot. All right, cool. So you know that there's a force pushing the ball forward. There's the arrow pushing it forward. And then the ball is going to push back on the bat. But what's important about this one is the size of the arrows. So the force of the bat is going to be much bigger than the force of the ball, and the ball is going to fly off. So let's take a look. There we go. Hand swinging the bat is big, ball pushing back on the bat is small. Last one. If I dropped this ball and it was falling through the air, what are the forces that would be acting on the ball as it fell? Pause the video and see if you can give it a shot. All right, here they are, gravity, and there would be a little bit of air resistance, slowing it down just a touch, all right? So those are force arrows, okay? And so what they show us is they show us the magnitude and direction of a force on an object, but what they also show us is a visual way of seeing it. And they also show us if the forces are the same, they cancel out. But if one arrow is bigger, that force overcomes the other force. And that's what we're going to talk about next, the resultant force. But for now, quickly go through your notes and just highlight the areas that show you understand this objective here, your ability to use arrows to represent forces. All right, keep it up. Keep up the good work, boys. Well done. Cheers.